Did you miss me? I'm back. 6-3, dividing fractions. Objective, to divide algebraic fractions, fool.
So, we're going to do some division of fractions. To save some time, we're going to assume no denominators are equal to 0, okay? For the sake of brevity. So, the division rule for fractions. What is the division rule for fractions? Remember we talked about before. Remember, multiplication, fun. Division, flippin' fun, man. That's what I call it, flippin' fun. Why? Because you flip, then you have fun. What's fun? It's multiplication. So you flip, then you multiply. You flip, then you have fun. But let's talk about the division rule. The division rule of fractions says that the quotient of a over b divided by c over d is equal to the product of a over b times d over c. Notice that this division changed to a multiplication sign, and this c over d became d over c. You actually took the reciprocal, or what I like to call it, the refliprical, boy. To take the refliprical, then you multiply. So basically, you never have to divide nothing, yo. Yeah, you just don't have to divide. Instead of dividing, you actually flip this guy, multiply, and everybody's happy. A times d over b times c. So flip it and then multiply. I like to call it flip then fun. For instance, if you have this, a over b divided by c over d, you write it as a over b times what? Oh, whoops, I didn't even flip it. D over c. D over c, man. You get a d over bc. Why does this always work? Well, I'm going to show, oh man, why did I start this? I didn't do a thing, but I'll show you right here. Scrap paper. Isn't that great? Why is a over d divided by b over c equal to a over d times c over b? Well, it's a fraction here, right? And any fraction I can multiply by 1 or any number and I get it back. So I'm going to go up to this fraction and multiply it by 1. And the one I'm going to multiply it by is going to be some number, like one that looks kind of like this, 3 over 3. We all agree that's 1, right? This is going to be like a wild one. What's this one going to look like? It's going to be c over b over c over b. Do we all agree that any number, c over b, divided by itself, c over b, is equal to itself? Because saying how many c over b's fit in c over b? 1. So that's the one I'm going to multiply this guy by. Watch. Multiply by c over b over c over b. Sorry, that should be lowercase b. So I'm going to multiply it by 1. Watch how nice this is. Taking this fraction, multiplying by 1, what do I get? Well, when you multiply the numerators and denominators. So I get AC over DB, don't I? And what do I get here? BC over CB, which is BC over BC again, right? Wasn't this number 1? Yes. So I end up having AC over DB over 1. Well, any number over 1 is just itself, so I end up with AC over DB. Wow! AC over DB. Magic! Magic! No, man, it's math, dude. It's math. It's math. We love it. We love it. We love it, so we dance. We dance. Who dances? This guy. I'm dancing for math. Ooh, ooh, ooh. That's the way I do it. Pop it and lock it. See? All right, now, here we go. What's next? Where did I leave off here? I get carried away sometimes. Look, I'm already 3.5 minutes into this thing and I haven't even started. All right, here we go. So quickly, how am I going to do this? This divided by this is the same thing as this times the refliprical of this. What do? I just flip it, man, and have some fun. So I say x over 2y times, flip it, 4 over xy is x4. Let's take out, we have products here, so I take this out here and this right here, and 2, 4, that becomes there, and that becomes there. So 2 left over there, and I get 2 over y squared. What about this one? This is 8 over this, divided by this. So what do? I'm going to flippin' fun, man. I'm going to take this guy, multiply by the refliprical of this. Division is flippin' fun. Division is flip. Then fun. Fun is just multiplication. Factor. X plus 5, x minus 5. Look for common factors. X plus 5, x plus 5. What about 18 and 24? Is there something you know that goes into 18 and 24? Isn't this 6 times 3? Isn't that 6 times 4? Yeah, there's a 6 and a 6. Look at me, I'm getting all messy. I'm doing this too fast. 3 over 4 times x minus 5. And I reduce that, baby. See what I'm talking about? Do you see? I'll slow it down a little bit. This is the exact same thing we were doing before. We're just taking the division, flipping it, and now we have a multiplication. Flipping fun, man. So let's do it. Let's flip this guy. So I'm going to end up with x squared plus 3x minus 10. I should have factored it right now in this step, but I'm not going to. I'm going to find the reflippical. End up with x squared minus x minus 12 over squared minus 4. Now let's factor this guy. What two numbers multiply to get negative 10 that add to get 3? Well, 5 and 2. Not add to get 3, sorry. Because it's a what two factors of 10 are 3 apart? 5 and 2. Now we look at the signs. That's another way to approach it. Well, whatever. Watch the factoring video. Okay, so we can factor this guy to x plus 5, x minus 2. 2 goes into this guy, so 2x plus 3 times this guy multiply to get negative 12. Well, what two factors of 12's difference is 1, 3, and 4. The larger one has to be negative. So I'm going to do x minus 4, x plus 3 over, difference of squares, x plus 2, x minus 2, and look for common factors because I'm multiplying. Just go across top and bottom, I get x and 3, x minus 2, x and 5 doesn't go anywhere, x minus 4. So I end up with these two on the top, and this at the bottom. Reduced. Alright, that's as far as I can do it. Those are the factors that don't end up reducing. The ones that are left. They had no common factors with the denominator. Alright, now here's a crazy one. So it's this divided by this guy. I'm dividing by this guy, then times this guy. So this is the one I have to flip. This is I have to find the reflippical of this guy. 2xy. So remember, this is 2x over y times 2x over y times 2x over y. So it ends up being 2 x over y divided by this, which is times the reflippical of this. So it's times y squared over x, right? Which is y over x times x over 4. Okay. So I'm just flipping this part here, okay? This times x over 4 stays. Now I look for common. Notice I have 2 times 2 is 4. I get 4 out of there. I end up with 2x cubed over y. Nice. Let's do another one of these babies. We're going to keep doing this. We're just going to keep on reducing. We're not going to stop all night. We only have 2.5 minutes, 2 minutes 15 seconds left, so we're going to try to do this. I'm going to factor this guy out. Notice this. I'm just going to flip this guy, and I'm going to see if we have any common factors. So here we go. C minus D is one factor. C plus 2D is another. And I'm just going to multiply across the top. 2D plus C is a factor. Nothing to factor out of that. There's a factor of the numerator now. Now this one I'm just going to flip it. So it's going to be times, if I flipped it, D plus C up top, D minus C on the bottom. D plus C's are gone. C plus 2D is the same as 2D plus C, isn't it? Nice. Now what did we talk about before? I have a C minus D and a D minus C. Remember what we have to do? The opposite of C minus D is D minus C. So another way I can write this, remember, negative C minus D, what is that? Look what it turns into. Negative C positive D, which can be written as D minus C. So the opposite of C minus D is D minus C. What I'm saying is if you want to switch the order of these guys, just make sure you take change the sign, put a -1 out here somewhere. Don't forget about it. And write this as C minus D. Now you can reduce. So I have a -1 here, 1 on top. The whole thing ends up being -1. Okay, I've got one more for you. Got one more, 1 minute. Can he do it? Let's see. Oh, this one's going to be a beaut. I've got this guy divided by this guy squared. I got to square it first. Oh my goodness. What do I end up with? R squared over R minus S, R plus S, R minus S up top, R plus S. And I look at this guy here before I flip it. I'm going to have R squared over R plus S, R plus S. So when I flip it, I have R plus S up here, R plus S up here, R times R. Those R's gone, those R's are out. R plus S, R plus S. Ooh. R plus S, R plus S, R, oh my god, I get 1 again. Okay, have a nice day. Have a nice day. I did it too fast. Sorry about that. Have a great day. Remember, division is flippin' fun. Next lecture, stick around because we're going to play, or we're going to talk about, we're going to do a little bit of booty.